In case you're wondering how it's made, I thought I'd put together this quick video on what goes into designing and cutting a foam wing. The first thing, using a few tools, such as CAD, which is used to draw out the outline and the shape of the wing, and we get some of that information. Another helpful thing online is eCalc. This is something where you can punch in the wing sweep, you can punch in the parameters of the wing. It will give you the aircraft CG range, so you can figure out where you want your motor to set on the CG, where you want the CG of the wing, approximate sweep, and the size of the wing, at least the size that you're targeting for. And then we draw it out on CAD. And then once we draw it out on CAD, we use another nifty little program. Let's get this thing here, which is a Dev Wing Foam. And what that does is, and I've got this already drawn in there, you go through and you take the wing and you literally draw it out. Well, you just set all the parameters in. You set the chord length, you set the placement of you set the, let's go to, there we go. Like, for instance, the airfoil, this particular one is using a Ritz 130-15, and it draws it out, and it does both the root and the tip. And this is actually a very good program. Anyway, it walks you all the way through, and you set things in like the cutouts we're doing to get rid of the ailerons. Here's one here, where you can see that we've got it set in there, and it will actually cut that out. And then once you get all that set, you go through and you apply the G-code strategy. What that is that just you set it up to it actually makes the G-code. Then we take that file once we've created it, and it goes over to the foam cutter. The foam cutter is this is a homemade one. This one uses a Windows XP PC because it's running Mach 3 software. Mach 3 software is the G-code interpreter for it. It's the same thing I use on my CNC router. It's the same one. A little bit of a messy desk over there. And once we load the G-code in, okay, then we're ready to cut the foam blocks. The foam wing blocks I've already pre-cut out. Those I literally draw out and make the plan form, and then I cut out the blocks using the same hot wing cutter, the wire, and just do straight cuts until I cut the block out. Now next, what we're going to do is we're going to set it up, and we'll actually cut the wing core out of it. Okay, now we're ready to cut the foam wing core. What we've done, we've got our G-code loaded up here. This is going to be the left wing panel of the Little Stinger. This is the V2, where I've kind of modified it because I didn't like the V1 that much. We've got the panel cut out, we've got our center line marked, and this is laid on the table in the center line. And then we're going to use the board and away. So now, we're to cut this code, what we're going to do is we're going to raise the wire up because it's got a home set. Okay, the wire is set at home right now. So when I go to 0, it goes to this one particular spot, which everything starts from. But because we need to heat up this wire, we're going to raise it up, we're going to pull it back, and we're going to turn the transformer on, which is down here, and we're going to let the wire heat up for just a second. Okay, now that the wire's heated up, we're going to go to our program. We're going to knock it to go to 0, so the wire goes to its 0 rotation, and then we're going to run the file. And now we just very simply just kind of sit back and watch things go. You can see the G code running on the Mach 3 software. Here, right now it's going through, looks like it's cutting out the back of the ailerons, which is going to get discarded. What we want is that I've got about a 40-degree angle cut in on the trailing edge, which will, where the balsa trailer ailerons will meet up to. You can actually watch in the upper right hand corner, it's got a MIDI of the hot wire actually going through the phone. The software automatically interpolates the speed for both sides. Obviously, in this particular case, this has a longer rate of travel because it's the root side as opposed to the tip. And it looks like we're just about done cutting this wing panel. And as that wire exits, we'll reach down and we will turn the wire off. And take the weights off of it. Now we have our core cut. And it's a matter of pulling it right up here. And we have our wing core cut. This actually has about 1 degree of washout that's cut into that wing core. And that's basically how it's done. Cut 2 halves. There's a different kind of setup for the center section. And glue it together.